Students, this is our last preview note of the year, lesson 4.4, similarity applications. We finally get to see what people actually do with this. Don't forget to give me both your location, date and time, and a parent guardian sign off. So right here we have a review problem. You should expect an equation, a graphing of a line on every single test this year. This is something we did on the quiz recently. It says write the equation of a line from a perpendicular goes through a given point. So we have two lines going through here. We have the given line, and then we have the perpendicular line. So step one, we should have already graphed the given line. Follow with me. Let's go ahead and graph that. That's -3, y equals mx plus b. Our intercept is -3. Our slope is -2/1. So I'm going to go up 2 and over 1 to the left because it's negative, or down 2 over to the right. It's the same thing. So this is your given line. Y equals -2x minus 3. Then we have the perpendicular line. I'm going to write y equals mx plus b. The only two things we need here is we need a slope and we need a y-intercept. So let's look at what we can do here. Because it's perpendicular, our slope has to be the opposite reciprocal. So it's going to be positive. Instead of -2/1, it's going to be positive 1/2. And then we want our b. Let's look at what we have. We do have an x right here. So we're going to plug that in for x, -4. And we do have a y here. We're going to plug that in here, plus your b. I want you to take 1 minute and solve for b. All right, let's take a look here how you did. You should have here, this is 1, this becomes -2 plus b. We're going to add 3 both sides, excuse me, add 2 both sides. It's going to become 3. So we have b equals 3. So our perpendicular line should be y equals positive 1/2x plus 3. Let's actually graph that and see if that works. So we have positive 3 up 1/2. And yes, they look perpendicular, and it should go through this point, -4, 1, which it does right there. Alrighty, students, so now let's recap our shortcuts to similarity because we're going to be working on those. Here are your keywords today: similar, angle, angle similarity, side, side, side similarity, side, angle, side. Pay very careful attention to units today, and of course, proportions, which we've been doing for 2 weeks. Our first shortcut you guys are familiar with is angle, angle. That basically says if we have 2 congruent corresponding angles, then the triangles are similar. This is by far the most common. So put a star by it, box it, something. That's by far the most common. Let's take a look here. Side, side, side. If we check our ratios here, let's go short to short. That's going to be a 2-to-1 ratio. Medium to medium. That is a 2-to-1 ratio, and then long to long, you see that's a 2-to-1 ratio, so my ratios are the same on all 3 sides. That's similar. Last one, let's check our ratio, short to short here. That's again 2-to-1. Long to long, 2-to-1, And then here we have an angle congruent. This is an example. That's side, side, side similarity. This is side, angle, side similarity. That's a quick recap. Now let's see how this is actually used in real life. I'm going to read this. I want you to finger track. So put your finger on your paper, and I'd like you to track with me while I'm reading, please. It says, Sean wants to measure the height of a large sequoia tree at Big Sur National Park with only a tape measure. On a sunny day at 3 p.m., a friend measured Sean's shadow and found it was 3 feet 9 inches in length. Sean's height is 6 feet tall. Exactly. The tree's shadow is 84 feet in length. Find the height of the tree. I'm going to set the timer for 1 minute, and I want you to simply do this, what's called draw, label, list, cross out. Don't actually solve for anything, but I'd like you to make a drawing, label your drawing, make a list of given information that doesn't belong in the drawing, and then cross everything out as you account for it in that. You got a minute, go. Ready? Let's see how you interpreted this. You should have right here, so we have a tree, and it's a big tree, sequoia tree. And so you should have a big sequoia tree. And as we do this, we are going to cross stuff out. So there's our sequoia tree. This is what I mean by cross out. And it says, on a sunny day at 3 p.m., a friend measured Sean's shadow. So we have Sean here. This is Sean. And Sean's shadow is 3 feet 9 inches. So he has a shadow. I'm going to make the shadow in red. That is 3 feet 9 inches. And Sean's height, I'll make his height pink. His height is going to be 6 feet. So it's a tall guy. And it says the tree shadow is 84 feet. So there's our tree shadow. And what we want is the tree height. Now, I don't know if you see this, but technically we have an imaginary triangle here. And a couple things. Anything built against the ground, we're going to assume makes a right angle. So we have a right angle. And when we're dealing with the sun, the angle, when you have sun and shadows, the angle up towards the sun is going to be the same for both. That's called an angle of elevation. So we know, first off, that these triangles are similar by angle, angle, similarity. They have the right angle and the angle back up towards the sun. Once we have a similarity, we're going to make a proportion here. Here's our x. Now, this seems real simple. I'm about to show you is wrong. So I'm going to copy it down, but you want to be very careful. What I'm about to show you is wrong. I'm going to go height over height equals shadow over shadow. So I have 6 over x equals 3.9 over 84. I want you to take a moment. There's something right about this, but there's something wrong. I want you to try to figure out what's wrong with this. Circle it and ask yourself, what is wrong with this proportion? Take just a second. Okay, students, so the problem with this, hopefully you caught it, is that's 3 foot 9 inches. That is not 3.9. So we have to translate this 9 inches into a decimal. The easy way to do that is just remember that's 9 inches, so it's out of 12. You're going to reduce that in a fraction. 3 goes in there 3 times, 3 goes in there 4 times. It's really easy to do this into a decimal if you think of money. 3/4 of a dollar is 75 cents. So our proportion is actually going to be 6 over x, that's height over height, equals 3.75 over 84. Now you cross multiply and solve. So here we're going to do 6 times 84 equals, make sure you hit the equal sign, divided by 3.75. And we get the height of our sequoia tree as 134 feet, 0.4. So that's 134. Okay, so students, if we're working in feet and inches, it's important to take this decimal and put it back into inches. So that is 4 out of 10, because that's a decimal. So we need to do something over 12 here. We want to get it back into inches. So I cross multiply. I have 10 times an unknown equals 48. We divide by 10, and look, Mom, no calculator. Your unknown is basically 4.8, right? So we're going to make it approximately 5 inches. So our final answer for the height of the tree is 134 feet, 5 inches. Let's try another one here. I'm going to read. I'd like you to finger track and read with me. Put your fingers right there. As it says, cell phone tower is 300 feet tall at 3 p.m. and casts a shadow of 152 feet 8 inches. The building next to it casts a shadow of 78 feet 6 inches at the same time of day. How tall is the building? I'd like you to go through this. Draw a label list, cross out yourself. I'm going to set the timer for 2 minutes, and I'll come right back and help you. There you go. Draw a label list, cross out. 2 minutes, go. All right, students, let's see how you did here. One step at a time. It says a cell phone tower is 300 feet tall. So we have a cell phone tower. It's going to be like this right here, our cell phone tower. And that is 300 feet tall and casts a shadow of 152 feet 8 inches. So here we have a shadow here. That's shorter. Let's draw that to scale. The shadow is 152 feet 8 inches. So 152 feet 8 inches. And then here we have a building right here next to it that we don't know the height, but it casts a shadow of 78 feet 6 inches. Let's close this up. Now, once again, because we're dealing with shadows, we have sun here. The angle towards the sun is going to be the same for both. That's called an angle of elevation. And that is going to be the same for both. Anything against the ground is a right angle. So once again, these triangles are similar by angle similarity. So we can make a proportion. Now watch our proportion here. I'm going to go left to right. Left to right. Always draw your little arrows here. I'm going to set one proportion up here. We're going to go height over height. So we got 300 feet over x equals 152 feet 8 inches over 78 feet 6 inches. Warning. That is not 152.8, and that is not 78.6. So we have to convert those to decimals. So I'm going to do that proportion down here. So that's going to be 300 over x. Let's convert 8 to a decimal. 8 over 12. 4 goes in there twice. 4 goes into that, and 2/3 of a dollar is approximately 66 cents. So this is going to be 152.66. And then 6 inches is 6 over 12, which of course is 1/2, and that equals 0.5. So this is going to be 78.5. I want you to take 1 minute, go ahead and finish that proportion on your own. Okay, so you should have solved. This is going to ultimately be 300 times 78.5. Hit the equal sign there. We're going to divide by 152.66, and we get 154.26 feet. So students, we have 154.26, so that's 154.26 feet. That's our height here, but we're going to change that feet again into inches, because that was our original unit. So we do 26 over 100, because that's a decimal, is going to be something over 12. So we cross multiply there, and we end up with 26 times 12 divided by 100. There it is. 26 times 12 divided by 100. And we're going to get at with 3 inches. So it's 154 feet, 3 inches. Let's try our last one here. I need to introduce something called an angle of reflection. When you look in a mirror, you get a reflection that bounces back to you. Angle-wise, when an angle comes in on a reflective surface, whether it's water or a mirror, and bounces off, this angle here to the mirror and this angle here, warning, those aren't vertical, but they are congruent. They're called angles of reflection. Angles of reflection, and they are congruent. They're not vertical, though. So here is a scenario. It says, legend has it that if you stare into a person's eyes in a special way, you can hypnotize them and make them squawk like a chicken. Here's how it works. In the diagram below, Ricardo is 6 feet 3 inches tall. So here's Ricardo. Let's put our information here. 6 feet 3 inches tall, and is standing 3 feet away from a mirror. If the chicken victim is 3 feet 4 inches tall, 5 feet 4 inches tall, how far away is she from the mirror? Now, anything against the ground has a right angle, so we can assume we have a right angle. And then we also know that the angle of reflection for both is the same. So we know these triangles are similar by angle, which means, of course, we make a proportion. I'm going to set the timer for 2 minutes. I want to see if you can't solve for this unknown distance completely on your own. Keep track of your inches and your decimals. Go. All righty here. So I'm going to go height over height. So this is 6 feet 3 inches over 5 feet 4 inches equals distance over distance. Again, I'm going left to right, left to right. Is going to be 3 over our unknown distance. Once again, we have to get these into decimals. So we're going to go 3 over 12. That's 1/4, so that's 0.25. And then we have 4 over 12. That's going to be 1/3, which is 0.33. So we have to get that in decimal format. So this is going to be 6.25 over 5.33 equals 3 over x. We cross multiply and solve. So we cross multiply like this, and when we solve, so we're going to end up with 6.25x equals 3 times 5.33. We divide by 6.25. At this point, I'll let you use a calculator. So we're going to go 3 times 5.33 equals, divided by 6.25 equals, and we get 2.55 feet, which is approximately 0.5 is 1/2. So this is going to be 2 feet 6 inches in distance. You have to be comfortable going back and forth between decimals and inches.